Next up, I'm going to show you how to solve the ALEKS problem, identifying mirror image twins. So what ALEKS is going to do here is it's going to show us four different carbon compounds, and it wants us to pretty much check a box or put a check mark under each of the compounds that exist as a pair of mirror image twins. So the tips for this question is we are looking for chiral molecules. And then with this question, we're searching for the carbon, which is in line with chirality. We're searching for a carbon with four different elements attached to it. And then kind of the pro tips for this one is as you look overall through the structure, you're going to write an X over CH2, CH3, or any carbons with the double bond. And the reason being here, like say we had this carbon that I put the X near here, because it has a hydrogen on this side, so hydrogen here and a hydrogen right here, it can't be chiral because, or chiral or have four different compounds because you had two, the same hydrogens attached to this carbon. And then also with the other carbon that's double bonded here to the oxygen, because it's double bonded, that means it can only form two more bonds and it can't equal four, which is why we'll eliminate it. So let's look at our first compound. We're going to follow the rules. So again, we're going to go ahead and write X over any CH2 or CH3, and we're going to write X over any carbon that is, that has a double bond to it. Next up, we want to see what carbons that we have left on this chain. And so we have one carbon right here, and you see that it is on one side of it, we have a OH. So I'll put a 1 near that. On the other side, this carbon up here, we have a CH3. So I'll put a 2 here. On this side right here to the right, I'm going to circle all of this because when it comes to determining four different compounds, this consists of side number 3. It's going to include everything to the right, not just this carbon right here, but everything that's attached to it. And I see that it's different from OH and CH3, so I'll circle that and label that as number 3. And then right here on the carbon itself, you see I'm going to put a dot right here. It has a hydrogen, so you in your mind, you can go ahead and just write a hydrogen down here, and you can put that as number 4. So next up, we just want to count to make sure everything right. So number 1, I have a OH. Number 2, which is up here, I have a CH3. Number 3, I have this carbon, which is attached to all of this stuff. And again, this counts as one complete compound itself. And then again, I have this hydrogen that's attached to the carbon in the center. As you see, I draw my arrow down here, and that's going to be carbon 4. So I can go ahead and check this as mirror image twins because it meet the requirements. Going to number 2, following the same rules, I'll write an X over CH3, an X over CH2, an X over this carbon because it's attached to a double bond, and the X over this carbon because it's a CH2. So I won't check this one because I could easily tell that the carbons on the carbon chain, are pretty much eliminated. So I won't even look at this one. I'm going to the next one. Write an X over CH2. Write an X over the one that's double bonded. But this carbon right here, I want you to remember my same rules. On this side right here, you see we have and I'll circle it, a CH2 and a OH. So this would be group 1. Over here, I have a OH, just a solid OH by itself. This will be group 2. Over here, I have a carbon that's double bonded to oxygen and a hydrogen. So I'll circle it, and this will be group 3. And then I have a carbon that's attached to a hydrogen right here, as you see, because it's CH right here. So I'll circle it, and that's where the hydrogen comes in at. And so that's 4. And I look to make sure I have 4 different compounds. So I got CH2, CH, or OH, that's 1. OH by itself, which is 2. On here, I have carbon double bonded to an O and an H on the other side right here. That's 3. And then just this hydrogen by itself. So that's 4. So it meets the requirements of being mirror image twins. I go to the next one. I see I don't have no CH2, CH3s, but I do have a carbon right here that's double bonded to O. So again, I'll X that off. I have another carbon over here that's bonded to O. I'll X that off. And so what I'll look for here is to see what's attached onto this middle carbon. So I see on one side I have a C, a HO, and an O. So I'll label all this as number 1. On top right here, I just have OH by itself. So this would be number 2. On this side right here, or the other side of the carbon, I have a C, a O, and an H, which is different from a C, O, and OH. So I'll write 3 right here. And then on this carbon, as mentioned before, because it has a hydrogen on it, I'll just draw the H right here. And I'll circle it, and that'll be number 4. So because that has 4 different elements or compounds attached, I will go ahead and put a check mark here as well. And then I added additional practice here at the bottom just so we can continue if y'all need a general idea. But quickly looking again, write an X over my CH3. That's not going to be 1. This is not going to be 1. This is not going to be 1. And then I'm going to look at the middle carbon, and I'm going to count what's around this. I see right here I have a CH3, so I'll put 1. And then I have another CH3 just by itself right here. So because I have these two, which are the same things, right here, because they're the same, I'm going to go ahead and scratch off this carbon, because again, you're looking for the carbons with 4 different things. From here, I'm gonna go over to this carbon and I'm gonna circle it. And I see on this carbon, I have a CH3 by itself right here and another CH3. So because I have these carbons is not gonna, I'm gonna go ahead and X that carbon. And again, following our rule, we already just put an X on all the CH2, CH3s. So this carbon and this compound will not count. Coming over here, again, follow the same rules. I write an X over my CH2, an X over my CH2, and I look at what's around it. Now I'm focused on this center carbon and see what I got. So on this side right here, I have a CH2 and an OH, so that'll be 1. But I see on this other side, I also have a CH2 and an OH. So because those are the same thing, you're gonna X out this carbon right here, which means that for this one, you won't have a check mark at all for either one of those. So again, this is fairly simple. You count you scratch out CH2, CH3, you focus on carbons that are on the main chain, and you make sure to see that they have 4 different things attached. So again, if you have a carbon such as in the middle right here, you're not only gonna count for the atom to the direct left of it, you're gonna count for like the whole composition of it to see if it matches up with what's on the other side. Again, if this video helped you or your classmates, feel free to like, share, and subscribe to the channel. Thank you.